relate the same properties to the nucleus, and then we say how they may differ or how they may be the same. Okay. And also we are also talking about some of the symbols like n, and we are also talking about the concept of quantum numbers and how they can be used. Okay. So the point was not to study the Bohr's theory, it was just being used as an analogy in this case. Okay. Now, अच्छा आप फ़ोटो भी बना लो, फ़ोटो का फ़ायदा होता है वो जल्दी अपलोड हो जाता है एंड समटाइम्स इट्स इजी टू फॉलो.
पहले ये पढ़ लें ना, उसके बाद जब लेक्चर होगा
हाँ,
तो ये भी बेटर.
राइट. Okay. So again I am talking from crane and the symbols used in crane. So L is the orbital angular momentum. You know, previously I talked about the general symbols and concepts. Now I am coming to crane and talking about the nucleus that we are studying. S is spin and small j is the total angular momentum or angular quantum number. These symbols have been explained in page number 36, which is chapter number 2. Okay. So it's like a reference, we go to back and forth. Okay. So nucleons like electrons have a spin quantum number of half. Nucleons like electrons have a spin quantum number. I'm sorry? हाँ, वो फ़र्क है, we are not saying they're the same thing, of course not. हम सिर्फ ये बता रहे हैं कि जिस तरह इलेक्ट्रॉन हैज़ अ स्पिन प्रॉपर्टी, इसी तरह द न्यूक्लियॉन्स ऑल्सो हैव अ स्पिन प्रॉपर्टी. एक बात. दूसरी बात हम ये बता रहे हैं कि जैसे इलेक्ट्रॉन्स का भी स्पिन का क्वांटम नंबर जो होता है हाफ होता है, राइट. इसी तरह इनका भी क्वांटम नंबर जो है वो हाफ है.
लेकिन इलेक्ट्रॉन का तो कैसे फाइंड होगा? जैसे हम प्रोटॉन का देखते हैं तो हम उसके अंदर क्वार्क्स वगैरह को देखते हैं, उनका स्पिन उनको कंपेयर करके जो प्रोटॉन निकलता है वो हम उसको असाइन.
अच्छा, एक्चुअली वी आर टॉकिंग अबाउट द न्यूक्लियस इटसेल्फ, वी आर नॉट गोइंग इनटू द क्वार्क्स. वी नो देयर आर क्वार्क्स देयर, वो फिर पार्टिकल फिजिक्स शुरू हो जाती है. ठीक है. ओके. So a nucleon moving in a central potential with an orbital angular momentum L and a spin S has a total angular momentum which is given by a nucleon has a total angular momentum J is equal to L plus S, right? Okay. So every nucleon can be labeled or described with the corresponding quantum numbers. Therefore, every nucleon can be described with the corresponding quantum numbers. L, S and J. And therefore, the total angular momentum of a nucleus, therefore, the total angular momentum of the nucleus containing A nucleons would then be a sum, a vector sum of the angular momentum of all nucleons. So, we are studying the properties of the nucleus, and we see that the properties of the nucleus depends upon the nucleons, right. So, यहाँ पे I would like to stress nucleus and the nucleons. Okay. Okay. So, the total angular momentum of the nucleus is called the nuclear spin. The total angular momentum of the nucleus is called the nuclear spin, and it is represented by the symbol capital I. Now, please pay attention to the fact we started with the angular momentum of a single nucleon, which is J, and now we are talking about the overall effect of the nucleus, which is I. Okay. So, so for many applications that we will be discussing and that you will be studying, the nucleus will be treated as one entity. We will not go into what's inside the nucleus, Hanji, because the spin becomes an overall property of the nucleus. Yes.
We are talking about the orbital angular momentum of a nucleon right now.
Right.
J. What does that term refer? It is not orbiting anything, or is it?
It is. Inside the nucleus also there are energy levels.
That's interesting.
That's interesting. There's a whole world inside.
And we also have the models, shell models.
Yeah, very good. Yes, we do. There are many models. Again, there are many things that we might not know, but there are some things that we do know, and therefore we try to understand it according to that. And this is what we know at the moment.
They can move within the nucleus like a particle in a fluid.
There's a lot happening inside. Yeah, but at the moment we want to look at the nucleus as a single entity. Okay, so let's look at the nucleus as a single entity. So this nuclear spin will become an overall property of the nucleus. There's another concept. अच्छा, you can make a photo. हाँ, बना नहीं, अब complete किया मैंने मेरे ख्याल. Okay, thank you. And there's another thing you will come across when you're studying this. And that is the Zeeman effect. So, we will just talk about the definition of the Zeeman effect. The Zeeman effect is
The splitting of the spectrum.
yes. So, whenever atoms emit or absorb radiation, right, in the presence of a magnetic field, you see that there are spectral lines which are split into polarized components. So, I think when you will be reading this article, you will come across this. So, that is why I am just giving the definition. Okay. So, I will write it here. An effect occurring when atoms emit or absorb radiation in the presence of a moderately strong magnetic field. So each spectral line is split into closely